This is our scientific literacy project. We are Group 3, which consists of me, Shamaya Johnson, Erwin Hurst, and Alexia Bent. Our project was based on the lab report of a buffered medium system for yeast batch growth culture. This PowerPoint will include slides of introduction and background, materials and methods, results, discussion, and conclusion. This experiment was based on using different buffer medium systems to help maintain the pH and regulate the growth of different yeast. Fungi, specifically the two yeasts that were used, are Cerevisiae and K. lactis. Both are frequently used within the biotech industry to create proteins for medicine. These proteins only work effectively if the pH is just right. It is necessary to buffer the pH in order to keep it stable. There were three main goals of this experiment, one being to evaluate how different medium compositions and buffer systems affect 1. The pH stability, 2. Medium acidification, and 3. The growth of yeast system. The second goal was to develop a medium system that helps keep pH stable without affecting yeast growth. The third goal was to test different pH ranges that are relevant for protein functions and antifungal testing. There were three different types of media systems that were used throughout this experiment. The first being a media system of ammonium sulfate only, the second being with only urea, and the third being a 50-50 mix of both ammonium sulfate and urea. Cerevisiae yeast was used for all three tests. Each test was tested at different pH levels, being 4.6, 5.6, and 7. Citrate phosphate and trace buffers were both used to help keep the pH steady. The results for each test, the first being the different nitrogen sources, ammonium sulfate caused the most acidification, which led to the pH dropping from 4.8 to 3.4. Urea caused an increase in alkalization, which increased the pH balance from 6.3 to 6.7. And the 50-50 mix gave the best pH balance and kept it more stable. The pH balance was between 6.1 and 5.7. The citrate phosphate buffers was used at 0.1x and 1.x. The 1.x CPB buffer slowed down the growth but kept the pH steady. The 0.1 CPB buffer had a decent pH and had less effect on growth. The 50-50 mix plus the CPB buffer had the best results, and it worked for other yeast species of K. lactis. Buffering at different pH levels. The 7 pH level growth was slow for both buffers, so it didn't really work. The pH for 4.6 and 5.6 increased the yeast growth, and it just had better growth overall. A neutral pH was harder to keep and made the yeast growth slow down and decline. The Trees buffer. Trees buffers did not work well for keeping the pH balanced. The 100 millimeters slowed down the growth, and the 10 millimeters did not work enough. Overall, this was not a good buffer system for this experiment. K. lactis yeast was also tested. The 50-50 mix plus the 0.1 CPB buffer was used. The pH balance stayed pretty stable, and there was no unusual growth.
So, yeah, slide 7 results. The K. lactis was the yeast organism that was being tested. They grew it in SD-8S urea plus 0.1 x CPV medium. They used the urea as a nitrogen source. As we can see, the pH stayed stable, meaning it didn't drastically increase or decrease, which suggests that the yeast didn't absorb too many acid or basic byproducts. And there was also no unusual growth, meaning the yeast grew normally with no contamination. or unexpected behavior that happened to it. Slide 8, discussion. The standard SD medium contains ammonium sulfate as a nitrogen source. But during the yeast growth, it may cause the medium to become more acidic. pH changes can interfere pH sensitive experience. Acidification can mess up experiments that are pH sensitive. Sometimes both good and bad. Stable pH is important for good results, so we try to keep it as stable as possible. EV was tested across different media types and pH levels to see which we could get the best, which they could get try and see the best result for. SD-AS/urea showed better pH stability than the other organisms. Tris/ACI was ineffective at maintaining a neutral pH. That it couldn't stay the same. And finally, optimized media as Sarah B say is the last one. The optimized media with CPB were successful growing both as Sarah B say, aka like disease strain without big pH. It didn't require a lot for it to grow. Yeah, I think that's it.
To sum up the conclusion, they developed a simple but reliable buffer media system that maintains a stable pH without harming yeast growth. For experiments at a low pH like pH 4 and 5 and 6, they recommended using 0.5 CPB. And for experiments that's around the neutral, which is 7.1 CPB, works best. The system especially is the system is especially useful for things like protein production studies, antifungal assays, and for any experiment where pH can affect your results. Overall, it's a great solution for anyone working with yeast cultures in a non-automated shake and batch systems. So our references came from the article that we had to read on. And any questions?